right, so I have my screen shared now. Is it clear?
Yes.
Okay, so let's discuss Android development core components. Before I begin, okay, welcome to Android development world. So like, I would like us to be interactive on this session, even though it won't be long, but I'd just like it to be more interactive. So you guys should try to like follow along as we are discussing. So I would like to know how's your journey so far. Tell me what you know. Like, just tell me about things that you know in Android development. Um, Maybe you know about activities, you know about services, or just tell me whatever you know. So I don't know who will go first. So just within a minute, just give me a brief about what you know about Android so far. I think we should start with Taiwo. Let's start with Taiwo.
Yeah, okay. Yeah, actually started Android ending last year. That was around September, October.
Okay.
And that's when I got introduced to them. And well, the journey has been, well, it has been very okay, but basics is more, I'm not, my Java knowledge is not that so in depth because I actually started Java around July, August. So after a while, I just felt like probably just switching to Android since what I've been learning, I wanted to actually probably just make it of use.
Yeah,
So
that's great.
yeah, so at the moment now, I actually know the basics of Android. So that means intent, activities, recycler view, list view. I think those are the major ones I know, and I'm currently learning networking.
Okay, yeah, that's great. Okay, is that all?
I think that's all for now. But I'm not that my Java is not that so strong, so I'm always having a little bit issues. I need to check online, things like that, just some little each.
Yeah, I understand. All right, so what about Olamide? Hello, Olamide.
Sorry, hello. Yeah, sorry. My network is kind of breaking a little bit. So, can you hear me?
Yeah, I can hear you.
Yeah. The to so to a large extent, yeah, like I don't know. I've sure been at it for a little while longer than like they started their own Android. So to a little more extent, I've probably gone more in like building like playing in a complete app life cycle and stuff like that. From the way activities are created, destroyed, the change, the states that you have to save and stuff like that, then to working with UI and other stuff, and also to data management, a little level. Because I've
Okay,
worked with MySQL and Room.
okay, that's great.
Let me see. And then with content providers, so and just complete cycle to a little bit more extent than probably the class because I've been at it for a little while longer.
Okay, that's great. So what about the last person?
Yeah. Just the basic stuff. UI, talking to an extent. I don't know anything about persistence. But what is, yeah, can you hear me?
It's breaking, kind of.
Okay, I think it's clear now.
Yeah.
Can I proceed?
Yeah.
So I haven't worked with persistence basically on the Android field of things. I don't think it should be before.
I didn't get that clearly. So you've not worked with what?
I've not worked with persistence on the Android side of things.
Okay, so what have you worked with so far?
Just doing layouts, activity lifecycle, fragments, networking to an extent, recycler view, basically.
Okay. All right, it's great. You guys are doing well, actually. Yeah. So first of all, I know the challenge must be having to for some of us, the challenge might be having to get our Java so strong. But the thing is, you should know Java, but you don't have to know everything in depth. You can always make the journey of Java and Android go together. Though it may be difficult, but you'll be able to get along with it. So yeah, so you just keep on pushing and keep on working with others to be able to get an idea of what they know and how you can build more of yourself. So let's move forward to the next thing. Okay, so how I got started, I was I was how will I say it? Okay, how I got started. Yeah, I started very bad. Yeah, that's because I developed interest in programming 8 years ago. Then I started with the Visual Basic. Visual Basic, a programming language. I think we're familiar with it. So uh, I built stuff with the Visual Basic is for building desktop apps actually. Then I remembered I just built some kind of mini applications. Then later I abandoned programming. Yeah, so then later I took up Java again. That was when I was in university. Then after I started reading up Java through one book like that. Then later I moved into Android. Then I started learning Android on my own. Then there wasn't really much boot camps or learning platforms. So you just have to take things on your own. So like it was a kind of difficult journey, but yeah, it was a worthwhile journey. That was how I started. Then later on, I interned at a company. Then from there, I also worked in another company where I started building stuffs, then published like that. So that was how my journey was. So how to get started. So like, the how someone gets started in the software world is very, very important. So like if you want to get started, like for instance now we want to go into Android development, the first thing is to pick a path you will like. So of which the path is the Android development which we've picked, which is a great idea. So usually some of us are like, I want to learn Android, I want to learn Vue, I want to learn this, I want to learn that. For someone who is not doesn't really have a specific task, a specific path, I usually advise that the person should stick to a path first for like maybe 6 months to a year, use it to learn a particular path. So if it's Android, be on Android for like 6 months to a year. Don't get distracted by you want to learn Python. It's not bad if you just want to go through the maybe basics of Python and see how it works. But having to now shift your focus away from Android to maybe Python, Flask, or Django to learn web development, it will be kind of distracting. So I usually advise just pick a path first and be good in it. Then next is to have a mentor. A mentor is very important. Yeah, a mentor is very, very important because whenever you run into challenges or whenever you want to grow, your mentor will be there to advise you, to help you and push you forward. So a mentor is very important. Then next thing is build stuffs and upload on GitHub. So it's very important to build stuffs, no matter how little it is. You should build stuff because it will make you know how things work. It will make you have hands on, and then you should upload it on GitHub so that you can always have a reference to it. Let me give you an example. When I schooled in University of Lagos in Unilag. Then in my final year, I developed an application for my department. I studied mathematics, so I developed an application for mathematics department. It's called Namsin app. If you go to Play Store, you'd actually see it's Namsin app. So I built that application. I used like let's say 5 to 6 months because I was also trying to you know, get my grades very okay and also build stuff. So I built an application and after after like 2 months after I released the application to Play Store, I only had the code on my external disk and on my PC. Later, my PC crashed and my external drive to stopped working. That's like 2 to 3 months later after I published that application on Play Store. Then I was like, man, I've lost the code, So then I wasn't familiar with GitHub. I didn't even know anything about GitHub. Okay, I usually hear about it, but I didn't know what it was used for. So like 6 months later again, after I lost the code, an idea came to my mind which I should implement in the app. Even some people in other levels were asking me about the code in case they want to improve on it, but like, oh, I lost the code. I couldn't get access to the code. So that was how I lost the code to that application. So that's why putting your stuffs on GitHub, not just GitHub, maybe Bitbucket or any Git system or any Mercurial system where you can always access your codes. So it's important to push your stuffs there. And also GitHub will also give you a good profile. When people are checking your repository, they know what you can do, they know your strengths, they know how your programming skills are. So that's about building stuff and uploading on GitHub. Then the next thing to do is collaborate with people or contribute to open source. So it's very important to work with people actually. Like three of you guys in the Android trial can, decide to work on an app. So when three of you are working on an app, you would see your different ideas. You see the way three of you think. You see the way you guys think. You'll be able to like understand how the other person thinks. You can use some of their thinking in your own side too. Like it's just, and you can also use that to help others, which will even make you improve more better in your coding. So it's very important to work with people, to collaborate with people. And if you contribute to open source, you're also collaborating with people, because an open source is an application that different people are working on together. So when you see people's source code, uh, you would you would understand how other people think, or you understand how something is structured. You will work with experts and you'll be able to mentor people also. So then lastly is stay updated. So as a developer, things change very, very much. So like for instance, we all know that Kotlin is the latest um, official language for Android development. So some of us might be thinking of switching from Java to Kotlin. Some of us might be familiar with Kotlin already, but that is just what you should do. You should stay updated. Stay updated with things that are changing in your environment, in the software world. So that is how you should get started. That's what you should have in your mind as you are working with the Android platform. So I don't know, is everybody following up with me? I would expect a
Yes.
response.
Yeah, we are
I'm
following
sure.
with you.
Okay, that's great. So I hope I was very clear on what I discussed. All right, so let me move faster. So the next thing is what employers look out for. Employers employers look out for someone who can build stuff. Like if someone that wants to employ you, well, he or she wants to employ you to build an application. So they are not just employing you because you know Java. They want you to build something for them. So employers want someone that can build stuff. So that is why you should always try to collaborate with people and build stuff, so that when it comes to you working for an employer, you should know how to build something. Then an employer also wants people who can build fast, because the world is a fast changing world. An idea that an employer have today, if the employer doesn't release it immediately, someone else might adapt their idea. So that's why they need someone to build fast. If you look at OP, for instance, now, OP had the idea of taking the ride-hailing market. They had the idea, but if the developers did not quickly turn out that product, it might hurt their business. Someone else might even overtake OPay. So, and if you look at GoCada did not make their app sophisticated. So they were not fast in making the app sophisticated. That is why OPay um, was able to like take over them. So employers want people who can build fast. So you should always think of how you can make things faster for yourself. Also, employers want someone who is versatile, someone who has a very large range of knowledge of things. So, if you know Android, how well do you know Android? Do you know it? Can you build an application such that it will scale? Can you build an application that, like can you build an Uber kind of application? Can you, at the same time, can you build a Facebook kind of application? So it's someone that has a versatile knowledge that can build such applications. Also, by versatile, you should also have knowledge of other kinds of software fields like backend, for instance. You don't necessarily need to know how to write backend code, but you should have an idea of how it works. You should know that, okay, in the backend, there's something I call an API, because as an Android developer, you always communicate with an API. So you should also have knowledge of those kind of things. There's database and stuff. So someone should be versatile. All right, so let's go deep into Android now. So this image is showing an Android system. So this is just an overview of what the Android system is. It's important so that we can know the things that we are working with. It's just like, for instance, you want to school in Lagos and you don't know the schools available in Lagos. You don't know that there are federal schools. You don't know that there are federal schools and there are state schools. You don't know that there is JAMB. You don't know that there is direct entry. You don't know that for you to get to a particular school, you need to take this route. So those kind of things, you need to know that they exist. You need to know them so that whenever you have an encounter with them, you will know that, okay, this thing exists. I should use this. I should not use this. So if we look at the topmost level of this image, we have the application. So this is where all the application we create, this is where it falls in. So in the application section where we have the home, contact, phone, browser, that is where our app that we create falls in. That is where apps like Uber fall in. That's where apps like Facebook fall in. That's where apps like WhatsApp fall in. So below it, we have application framework. So what this application framework means is that these are the components, the components that are used to build. These are the immediate components that are used to build these applications. So like we have the activity manager, window manager, and stuff like that. So the window manager is just like the frame in which your WhatsApp sits on. So like when you click on your WhatsApp sits on a frame so that it can display to you. And the activity manager is that activity that you are seeing, that chart you are seeing is an activity. So that is where this application framework comes in. If you go deeper to the next level, you will see libraries. Now, this libraries is a more deeper component. So like we can see SQLite for those of us that have worked with persistent storage. So SQLite is the database, the internal database for the Android system. So this is where you store data. So imagine an application like a WhatsApp that keeps your data. Where does it store it? Then you will know that, okay, there's a kind of SQLite communication there. So if you want to work with something like database storage, storing a data, you know that, okay, you have to run to SQLite. And you know that if you have to work with maybe graphics, some kind of high graphical components, then you use this library called OpenGL. So these libraries are very useful also. Then beside the libraries, we have Android runtime. In this Android runtime, we have core libraries and Dalvik virtual machine. Now, this Android runtime is what makes the Android to run these applications. Because if you create these applications with these libraries, how will they run? So it is this Android runtime that sits on this Dalvik virtual machine that makes this application run. Then below the last level, which is the Linux kernel. I suggest, I think we are familiar with Linux. Linux is a kernel. So what does this Linux kernel mean? It's just a layer where you have all these drivers that can interact with a hardware. So it means that if you want to, you know, probably you want your phone to maybe kind of work with, um, you want to read in a USB, like we have these OTGs now. Probably you want to read in a drive and you don't want to use a library. You can just use these tools. So this is how the Android system comes up, from the Linux kernel to the Android runtime to the libraries to the application framework and to the applications. That is how we have all these applications that we use. So moving on to the next thing, which is your application. So we are all familiar with how the applications look like. This is an example of the messenger app here. So I think we are familiar with how applications looks like. So the next thing is delivering applications, the build system Gradle. So what do I mean by delivering applications? Delivering applications, from the word deliver application, it means how do we give our applications out? Before after as a developer, after you've used your activities, your recycler view, your card view and everything with your retrofit, and you finish the application, how do you then push it out? First of all, you need to build your application, and that is where the Gradle comes in. I'm sure we are familiar with the Gradle. The Gradle is just a system that helps us build and automate tasks. So if you look at, we said the Gradle system builds Android projects to ensure it meets specific requirements. So what does this mean? It means that by the time we are done with our application and we build it, it ensures that um, it ensures that it meets specific requirements like the API level, like um, the linting your, like inspecting your code if they are correct, if there's no syntax error and stuff like that. So it helps us build our project to ensure that everything will compile, all your codes will compile successfully. I think we're all familiar with the fact that Java is a compiled language. So the Gradle system will help us also make this process faster. The Gradle system also helps us include third-party libraries and plugins to our projects. So, like sometimes we want to use libraries like retrofit. It is in this Gradle that we're going to specify that, okay, Gradle, I want to use this library. Help me include it into my project. So the Gradle system will help us put in the library, and also build our project, so that to ensure that it's going to work correctly. So moving on to the next thing, we can say that the Gradle system also helps compile our Java files, dependencies, and resources to an Android app. That's an APK. So what this means is that whenever we are done with our task, the Gradle system will help us build it. So it's transformed the Java files to a .class files, which is like a bytecode. Maybe some of us might be familiar with that. So the Java compiles, all the Java codes that you write, it compiles to what they call bytecode. Then this bytecode plus the resources, that's where you have your strings.xml, your dimensions and everything, your images and drawables. It combines them also along with your dependencies and forms it into a dex file. So you can say I have this arrow string from Java to class to dex. So from this dex file, the Gradle then uses this the package manager to help us sign our application into what we call APK. I will show us a graphical explanation of what I'm saying in the next slide. So another thing that the Gradle also helps us do is to automate tasks. So it's things that we're supposed to be doing one by one. We can specify it in Gradle to help us do that. So okay, before I come to this demo is just to show us our Gradle system. but I think we are familiar with it. So let me just open this so I can just explain some basic things in Gradle. Okay, so as you can see here, for an Android application that we create, we always have two Gradle files, one for the project level and one for the app level. So it is the one in the app level that you are going to use to specify your dependencies. So if you take a look at it, okay, it's still building. Just let's give it a few minutes. Okay, so if you look at this build.gradle, this build.gradle is the one in our app level. So I'm sure we are familiar with the fact that we have two Gradle files in an Android project, one for the app level and one for the project level. So the one in the app level, I don't want to go I don't want to go very deep, so I'll just explain briefly. So there are some times where you can modularize an application, just like now, for instance, if you look at the Uber app, the Uber app has a section for the riders and for the customers that search for a ride. So you can build those two applications in a single project by using what we call modularization. So when you modularize an app, when you modularize such an app, you have two different apps. So in those two different apps, you can have two separate Gradle files for that apps, because the dependency that the rider app will want to use can be different from the dependencies that the customer app will use. So that is the essence of this Gradle file in this app project. So regardless of the fact that there are two different apps in a project, we are still going to have a project level build.gradle, which is the one that we'll see here, this one. So this one is just to specify something general to the whole project. Like as we can see on top here where we have build scripts, we can say that we have extension Kotlin version. So this one is stating the version of the Kotlin we're going to use. So we know that the app, let's say for instance, we are going to write the whole app in Kotlin. We don't need to be specifying that for the rider app we don't need to specify it in the rider's Gradle file that we want to use Kotlin, and go and specify it again in the customer Gradle file that we want to use Kotlin. So instead we can just place it here and say we want to use Kotlin and this version. But in the app level, we can specify dependencies. So looking at this Gradle file, we can see the compile SDK version. So what this compile SDK version means is how the targets, the API level you want to target your app to. So your app is going to compile and check for nitty-gritties corresponding to this compile version that you state. So if, for instance, you want to compile for, let's say, Android 4.0. Android 4.0 is like Android ice cream sandwich version. So if you are compiling for that version and you are using features that are meant for Android 9.0 or Android 10.0, which is the latest, you will have a compile error, because you say you want to compile for the 4.0 and you are writing codes for a feature version, so it would not work. Then this build tools is the tools for that particular API. So the tools for that particular API is what will now help you build your application. So here we have default config, which are the configurations for the project. We have build types. Build types are like environment variables. And we have the dependencies, where we specify our dependencies. So that's basically what we have in Gradle. So moving on to the next slide. So this is a graphical explanation of how the Gradle system compiles our app. So we can see on top here where we have the app sources and resources. That's where we have your Java files, your drawables, your strings, your XML and stuff. Then you can see I also circled dependencies. So it takes the Java files and the dependencies, the third-party libraries you are using. So that is, let's say, Retrofit or RX Java or other things. So it combines the two and compiles them. You can see the compiler here. So it compiles them, and then it packs all what it has compiled and turns it into what they call decks. So these decks and other compiled resources are together. Then from here, it now takes it to the packager and signs it with a key store. So we can see it here that we have the debugger release key store. It signs everything that we have here with the key store and places it in this packager. Then it's from this packager that it now releases an APK. So we shouldn't be too overwhelmed with all these details. That's why I put calm down. You don't need to know every single detail. So all you just need to know is just how things work. You don't need to know every single detail. All you just need to know for now. If you're not really grounded, you just need to like know how it works and know what is available, so that whenever you encounter a problem that requires you to do some tools, then you will know that, yeah, I've heard of this before. I've heard of this before. Okay, this is how this one works. This is what I need to use, and this is what I need to do. So I don't know. Are we all following? Is it clear? I'm expecting a response from us.
Yes, yes.
Only one person voiced.
Yes, you're on track.
All right, that's great. Okay, so basically all what I've explained so far are just how the Android system works and how the applications are being built. So they are very important because whenever we run into troubles, we should know where the trouble is coming from. So there are some times where we might be coding and run into troubles that has to do with Gradle. Then we'll be confused and we'll be thinking it's from our Java files and stuff like that. So it's very important for us to know how things work. There are sometimes that some errors are from a device that you use. So there are sometimes that the error can come from the devices that you use. That is why you need to understand how the Android system is organized, how it works. So that's the essence of me explaining those basic important details. So let's move on to the next thing. So the next thing here is, how does an app know what to open when you click on the launcher icon? So who can answer that question? How does an app know what to open when you click on the launcher icon?
Checks your Android manifest.xml.
Yeah.
The activity where you have an intent filter declared, I think launcher, category launcher, action, so.
Yeah. That's very great. So that is exactly how the Android system knows what it will open whenever you click on an icon. So okay, so how does an app know what to open when you click on the notification that comes up on your phone? Is also through the manifest. You have to specify all those information through the manifest. So that is why we are discussing about the Android manifest file. So the Android manifest file is a very important component of the Android system, because that is where the Android system knows what is going on in his, like your phone, for instance. Now, your phone is an Android system. So whenever we are talking about the Android system, I want us to not only limit ourselves to phone. The phone is not only the Android system we have. We have the watch. We have the watches. We have the Android TV. So anybody can decide to use your app on any of those platforms, or you might be developing for any of those platforms. So you need to take into consideration whenever we mention the Android system. So in any of those Android systems, the manifest file is what the system would use to know what is going on in its system. So for your own application, it is your manifest file that is going to that is going to interact with the Android system, that system will, this is me, I'm an application, and these are the things I have. So if you look at the manifest file, it always have the activities, services, content providers, broadcast receivers, and so on like that. Then also, there are some times whereby in an activity, you have to specify some particular action, like the launcher, like the category launcher and the action main. It is that filter that is telling the Android system that Android system will, whenever you click on this particular icon, like you can see that the application section of the manifest file has an icon. So that is what is telling the Android system that whenever I'm being clicked, I want you to help me open this activity. So we can see that it is not the code that we write that determines what will be clicked on. It is the manifest file that will now link it to our code. So that's why the manifest file is very important. So the manifest file is used to define entry points for an app. So the entry points can be from anywhere. Like for instance, whenever a notification, like when you guys receive a notification from WhatsApp, when you click on it, it just goes to the person's chat straight. So how does it know that it's supposed to go to the person's chat straight? That is because in the manifest file, or in a somehow way, it has been defined here that, okay, I want this particular activity to serve as an entry point from somewhere. So that entry point, you have to specify it in the manifest file, or else the system won't know that such entry points exist. Also, the Android manifest file is used to define requirements and permission for an app. So like Uber app, for instance, Uber requires your location. It requires to get your current location and how, whenever you are moving, it requires to know your location as you are moving. So that permission, you also have to specify it in the manifest file. Not just permission, there are also some features that you might need. There are also some features that you might need. Like for instance, if you want to use Google Lens, for instance, Google Lens requires some kind of features from an Android phone. You have to specify that in the manifest file. So the manifest file does not only talk to the Android system, it also talks to Google Play Store. I don't know if you guys are following.
Yeah,
So,
well,
right. So the manifest file also talks to Play Store. That's why sometimes if you try to access, okay, I remember earlier last month, I was trying to download there is this app. I think it's OPay app. Yeah, I was trying to download OPay app on one phone like that. But when I opened Play Store, I couldn't find OPay app on Play Store on that phone. So in my mind, I was thinking, as OPay removed the application on Play Store, then I now use another person's phone to check if it's on Play Store, and I found it there. So from there, I was able to notice that, okay, it means that this phone has some features that is required from OPay. The phone I wanted to download doesn't have the features that OPay's app required. So the manifest file is what talked to Play Store that I want this app to be available to only so and so kind of phones that have these specifications. So those things are important so that your app doesn't go into where it's not supposed to go to, so that you can have a great user experience. So the manifest file is also used to define Android components used in an app. So that's where you declare your activities, services, and broadcast receivers. So now let's talk about activities. Yeah, I know we are familiar with activities, so I'll just be quickly brief in this. Well, so let's just go. So activity in simple terms is a screen of an app. So from this slide here, we can see that this is Gmail's app. So we can see that firstly, we have the inbox. The inbox is an activity. When we click on a message, it takes us to another screen. That screen is also an activity. When we click on compose message, that compose message is also an activity. So an activity is just basically like a screen of an app. So a typical app consists of several screens. So which means that there must be several activities for it to have several screens. So it's not like the Gmail's app has several activities in it. So it means that as they have several activities there, they have to define those several activities in the manifest file. Now, how do we create activities and what is activity lifecycle? For us to create an activity, we have to create a Java file. So I think we are familiar with that already, how to create an activity. So the Java file must extend the activity class or the app compat activity. So I believe we all know that there is an activity class. That activity class was the first, base class that Android first of all started using. So the activity class is what they continue building, that they now got to app compat activity. The app compat activity was built to enable backward compatibility of applications. So it means that your Java file must extend that app compat activity. So once you've extended that app compat activity, you must now create your UI in an XML file or Jetpack Compose. I'm not sure if most of us have heard of Jetpack Compose. Maybe some of us might, but Jetpack Compose will be the new way of us designing a UI. But for now, let's just work with our XML. So we don't need to bother ourselves about the Jetpack Compose yet. So after you've created the Java file and you've extended the app compat activity, you've created your UI in the XML, then you now need to register your activity in manifest file. So this is an example of an activity class. So we can see, firstly, we have the package where the app belongs. So they have these two imports. Then from there, we now have the class. So we can see that the class is extending app compat activity. So I'm sorry, I don't know if you guys are familiar with Kotlin, because this is a Kotlin syntax. I was thinking probably you guys, were you guys taught with Kotlin at all? I would like to know if you guys were taught with Kotlin.
No, with Java.
Only with Java. Okay. Well, Kotlin is not hard at all, so you don't need to think there is a different programming language. Kotlin is also like Java. It's also expressive like Java. So it just takes away some pain in Java. So like we can see here that instead of having extends app compat activity, we just have a double colon. So represent that extend. So so your normal at override public protected void on create. So it's just override that we have here, and we have font to represent that is a function, and we have the on create. So this is basically an activity. Then we have the XML. We can see that we are referencing the XML file here, out.layout.home. So then we can see that we have it in our manifest. So that is how we create an activity. So now, what is activity lifecycle and why do we need this lifecycle? So there are some times when users perform some actions. Like sometimes when we want to watch a movie on our phones, we prefer to watch it in a landscape view. So so it means that if you want to watch it in landscape view, you rotate your phone. When you rotate your phone, a lot of things happens. So as a developer, you must take into consideration whenever someone is using your app and rotates his phone. Now, whenever a user is using your application and the user rotates your phone, your activity goes through different life cycle stages, which I think we are familiar with. Now, as a good programmer, whenever those activity life cycle occurs, there are some times that we are using some resources, and whenever this activity life cycle occurs, we must drop that resources. Like for instance, you are using Uber, or let's say you're using Google Maps to go to somewhere. You are walking, you are following the direction. Then a call just comes in. You know, when a call comes in, it will definitely overlap your screen. So whenever that call overlaps your screen, your app, the Google Map app, goes into the life cycle called on pause. So it will go into the lifecycle called on pause. And when you pick the call, it's going to the on stop lifecycle. On pause and on stop doesn't kill the activity. It keeps Google Map in the memory of your phone. That is why you can always go back to it whenever you access it. But at that moment, when that app goes to on pause and on stop mode, you are no longer using that application again, isn't it? So it means that if you are not using the application again, why should Google Maps still be trying to show you your current location? Because it needs a lot of energy from your battery to be able to connect to the satellite and bring in your current location. So instead of it having to consume your battery, let's assume you are trying to meet someone at maybe Las Vegas now, and and it's only 2% you have. Now that 2% is what you are just trying to use. You are trying to use Google Maps to locate where the person is, and a call comes in. So instead of their app draining your battery while you have that 2%, that on pause mode pause is used to pause that action of having to get your current location. So by the time it pauses that action, it would not consume your battery, and make it will not make your phone go off. There are some times whereby that resources, let's say that phone call needs that your current location. It means that the Google Map and your phone and the phone call will have to be fighting for that resources, which will cause a conflict. So therefore, as a good programmer, you should always take into consideration those life cycles. That okay, whenever a user is in this life cycle, it means that this person doesn't need this thing again. So let me release these resources. And you know that phones now, most phones nowadays have this system of showing which application is consuming battery. I know some people that are very angry at apps that consume battery. They will just uninstall your app, and when they uninstall your app, you've lost user, you've lost money. So that is why activity lifecycle is very important. So I'm sure we are familiar with the on create, on start, on resume, on pause, and on stop, and on destroy.
Yes.
Yeah.
All right. So this is just an example of this is just an example of how you implement the life cycle in Android. So we can see here we have the on start, on resume, on pause, on stop, and on destroy. So well, this one that we see here is the way we normally implement it. But since last year, there's what they call life cycle aware component. So you can also define life cycle components like this. So we can see where this Microsoft is on life cycle events. Here is saying when the life cycle is on create mode. So what this one is doing is that instead of us having to place our function, the code I want to run inside the lifecycle, we place the lifecycle on the function. So it means that if I need, let's assume I need these two functions, load user details and receive location updates. If I wanted two of them to run in on create mode, instead of me having to write these two codes inside on create method, I'll just use this annotation, this Java annotation at on lifecycle events on create. I'll just use on both of them. So we can also do it this way. It's called lifecycle aware component. So we can always check up on that. All you just need to do is you need to implement the interface. So what this Kotlin code here is doing is extending app compact activity and is implementing lifecycle observer interface. So when you implement this, then you now have to, in this onCreate method here, you should add this observer, lifecycle.add observer. Then that's when you can now use these guys here. So I don't know if I'll be given extra time, but I still have some nice things to share. So I don't know, is the moderator here? Can I continue?
Yeah, I think you can go on.
What did you say?
Yeah, you can go on. I think you should.
Go ahead.
Okay. So I'll try to round up in like 30 minutes.
Okay, that's fine.
Sorry, I didn't get you.
Yeah, I said that was very fine.
All right, all right. So I don't know. Can I hear from you guys? Is it going fine? Am I making things clear enough, or I'm not making things clear enough?
Yeah, you're doing well. You're okay with
Sorry,
it?
please don't to ask one question from the previous slide. It's about cutting. Okay,
Okay.
yeah. If you are going to implement another interface, will you
Okay.
put another comma after that lifecycle observer?
Yes, you will.
Okay, so that the second comma is like representing implement.
Yes, yes.
Oh, okay. Thank you.
All right. All right. So the next next thing we are talking about here is activity plus ViewModel. How many of us are familiar with ViewModel?
I think I've done something.
There's someone that's having a noise on the call.
Okay, I said I think I've done something before.
I can't get it. It's like nothing is working.
Hello?
Okay, yeah, it's clear now.
Okay, yeah. You asked about view model.
Yeah, I was asking if there's anyone that has worked with
Okay.
ViewModel.
Yeah, I said I think I've done something with it before.
Okay. Sorry,
Yeah.
who is this? Is this
This is Olamide.
Olamide? Okay, okay.
Yes.
So who else? Okay, so I think it's only Olamide. Okay. Okay, let me just explain the purpose of ViewModel. So in Android, there's this thing that we call ViewModel. What the ViewModel comes from the architecture that Android has decided to implement. What an architecture means is how you present data to your UI. So that's basically what it is. How you present the pattern you're going to follow in order to present a data to your UI. So the purpose of this view model is for you to be able to keep data so that whenever a user rotates his phone while using the application, this data does not get lost. Now let me give you a scenario. So there is this I don't know if you've worked with async task before. How many of us has worked with the async task class?
No, not work with it.
You've not worked with it? Okay. So nobody has worked with async task class, right? Okay, okay, no problem. So in the async task class, the async task is used to run a short background operation. Like let's say let's say you are creating an application like, let's just use WhatsApp for example, and you want to retrieve the chat for a particular user. You can use an async task to fetch that data, that you want. So now imagine when you are fetching that data, someone rotates the application. Now, when we all know that whenever an application is rotated, the activity is destroyed and created again from the beginning. That's where the life cycle comes in. So whenever someone is in a portrait mode and is using your application is going to be in the on resume state. But whenever the person rotates your application, your application is going to go through the on pause, which is what we have on this slide. So your application is going to go through the on pause state, the on stopped, and on destroy. Then it will now go back to the on create here. So it means that if, for example, you've started running that async task, and let's say you have gotten some data, and let's say you're still trying to get some data. By the time that person rotates, that data is gone. So it means that you have to refetch that data. So what that means is that you are going to have an unstable app. So in order to avoid having to place your data on this life cycle, that is where the view model comes in. So the purpose of the view model is to be able to help avoid that that rotation and data loss. And also there's something that they call memory leak. So memory leak usually occurs when you're using async task. Though async task is not, is advised not to use async task anymore. So, but I won't bother you guys with that for now. So let's just go into the next thing. So I would have loved to have a short demo on using ViewModel. So let me just be fast with it so that I can show you guys how to use it. So basically, if you have an activity like this, okay, you know, I just created this application. So if, assuming we have an activity like this, it is always advisable to create a view model for this activity. So how do you create a view model? All you just need to do is create a new class. So let me create a new Java class. So I'm going to call it main activity view model. So this class, I'm going to extend it to hold the view model, this view model. So in this view model now, I can place in any data. So let's say, for instance, I can place in private. Okay, let me make it private yet. Let me just make a public string username. So I'm keeping this username here. Why? So that in case this username changes, let's assume I'm trying to fetch this username. Let's say the person change his username, or let me say first name. So imagine someone changes his first name, and while fetching it, the person rotates the app. So instead of this main activity here, instead of it disturbing my getting of that data, my view model will just handle it for me. So the view model doesn't break or doesn't have a life cycle. It's not attached to the main activity. It's not attached to the main activity's life cycle. So that is why it's kept separate. So the way you can now access this first name in the main activity is by, okay, I need to import this dependency, implementation 100x. Okay, let me quickly search for 100 lifecycle dependency. So I just want to quickly show us how we can implement the life cycle and the view model. So I need to import this third-party library. Okay, so it's building and it's done. So for me to use, if I want to access this first name, I have to, first of all, get a reference to my view model. So I will say private main activity. Okay, sorry, this is Kotlin. So should be equal to let me use this. View model. Okay, I think I'm missing a dependency. Okay, so I'm missing this dependency. So I'll place this dependency here. So now I can access this here. Just a few minutes. Okay. So I was missing the Kotlin version of that dependency. So all right. So this is how to use it. Okay, so sorry for the delay in time. So this is how to use the view model. So now I can now say main activity model dot first name. So you can see that now I can access this here. So it means I'm going to perform my network operations here. So I can say public void fetch first name. So I can always set my first name here and I can get it here. So when when the user rotates the application, or if there is something that requires it to get destroyed and come up again, it is only this main activity that gets destroyed. This main activity view model here doesn't get destroyed. So all your data still remains intact. Yeah, so I don't know if it's clear. Is this clear to every one of us here?
Yes, it is. It's
Yes.
All right. Okay, so let's continue with this. So we move on to fragments. So most of us are familiar with fragments, right? So
yeah.
what are fragments? So just in simple terms, So fragments means part of something. So when you're talking about fragments, it means something is part of something. So in Android, fragments is just like part of an activity. So like example, in WhatsApp, when we have different tabs, when we open WhatsApp, we see different tabs. We have the chat, the status, the call, and the camera. So those things that you see are fragments. So it's just like an activity, but it's not totally an activity. It just has a slight difference from an activity. So like you can see this WhatsApp, we have the chat, status, the calls. So the chat itself is a fragment, the status itself is a fragment, and like that. So fragments also have life cycle. Why do they have life cycle? The same reason with what I explained about activity. So that's why they also have life cycle, because whenever they are being rotated, they also go through that life cycle stage. So fragments just have some additional life cycle, which is the on-create, view, on-attach, and on-detach. So we can see an image here. So we can see that this image here is showing us that in an activity has on-create, on-attach, fragment. So one thing we should note is that you can't have a fragment without an activity. So a fragment always attaches to an activity. So it means that whenever you want to create a fragment, you have to create an activity first. Then when you create that activity, that's when you now have to bring in the fragment. Remember we said a fragment is like a part of an activity. So it means that you can't create a part of something without that thing being in existence. So whenever an activity is created, that's when we can now create a fragment. And a fragment will undergo this portion of life cycle: the on attach, on create, view, on activity created, on start, on resume. So this is just when you open a fragment. The full life cycle, this is a full life cycle of a fragment here. So we can always check up on that. So fragment also have a view model. So the same purpose of the view model of an activity, the same purpose of why a fragment has a view model also. So a shortcut. So if you don't want to start creating your view model manually, Android Studio has a shortcut for that. So if you go to File, if you open Android Studio, if you go to File and you come to New and you scroll down to fragments here, you can see fragments with view model. Once you click on that, you get your view model and you get your fragment here. So that is how the fragments and view model work. Okay, so how do you create a fragment? So first of all, you know that we have to have an activity. So after you have that activity, that's when you can now create a class. When you create a class, that class now has to extend a fragment. After you created a class that can extend a fragment, then you now go back to that activity and you begin a fragment transaction. After you begin a fragment transaction, you add or replace the fragment to a stack. So fragments work in terms of stack. They have a stack. So after you create that stack, after you add it to that stack, then you commit that transaction. So I will show you a demo later on that if you have time. So let's move into the next one. So this is a question for us all. How do you navigate between activities and how do you pass data between activities? So can we answer that question? Hello, everyone.
Hello?
Hello.
Hello?
Yeah.
Hello, can you hear me?
Yeah, I can hear you.
Okay. Yeah. Intent.
Sorry,
And
there's some kind of noise from your side. I don't know.
Can you hear me now?
Yeah, it's clear now.
Okay, sorry about that. Intent and You put intent extras. That's how you pass the data between them.
Okay, is this Olamide?
Yes.
Okay, okay. So anybody apart from Olamide that has a different answer? Okay, so I think no one has a different answer. So yeah, it's actually intent. Use intent to navigate between activities and pass data. So actually, intent is not just used, is not only used to navigate between activities and pass data. You can use intent to pass data and interact between any Android component. So example of Android components are services, activities, fragments, broadcast receivers, content providers, pending intent, and stuff like that. So you can use an intent to interact between any of those Android components. So as you can see, yeah, I said it can be, you can use intent to start another activity. You can use intent to start another Android component. That means you can use to start a service. You can use to start a broadcast receiver. You can use intent to pass data from one Android component to another Android component. It means that you can use intent to pass data from one activity to another activity, or from one fragment to another fragment, or from one activity to a fragment. So like you can use intent for various things. Okay, so I'm supposed to do a demo here, but doing the demo would take time. So I believe with the experience that you guys have, you are familiar with fragment and intent and activity. Yeah, so,
Yes.
all right. Okay, I have some more talk about intent, but I won't go deeply into that. So this is another question for us. How does Twitter load its content and images efficiently? So what I mean here is we can, whenever we open Twitter, we see that it loads different feeds for us. It then, I don't know if you notice something. If you open Twitter without internet, you would notice that some feeds or some tweets don't have the images displayed. But if you turn on your internet or your mobile data, those images will now load. Now, having to do all those process, having to load the tweets and the images and everything, what do you think Twitter uses to make sure those things load efficiently? Who can answer that? Nobody? Okay, so
But
I didn't get that.
can you hear me?
Yeah, I can hear you.
Yeah, I said I'm not sure at all, but just a guess, sure.
Okay,
The background threads or something like that.
okay.
And
Does
then when it
anybody?
runs the background thread, it caches the like some of its feeds, it caches some locally, and I don't know, maybe something around that.
Okay, okay. Does anybody have any
Huh?
other answer? Does anybody have any other answer to that? Okay, so okay, yeah, you are kind of on the right track, Lamide. So basically, it's just in general terms, background operations. They're just sorry, I'm having a little network. All right, it's clear now. So it's basically background operations that are being used to make those things happen efficiently. Now, background operations are used in most applications because all applications want to deliver efficient user experience. So in Android, the background operation is called services. So what are services? Services are basically they are an Android component that the purpose is to execute long-running and intensive tasks. So there are some things that you can actually use to run um, stuffs in the background apart from services. Like you can use async task to run operations in the background, and async task is not a service. You can use Kotlin coroutines to run a background operation. Kotlin coroutines is not a service. But whenever you have a long-running intensive task, like let's say you want to process an image, you want to perform some operations on an image, or you want to load, or you want to upload some user data, like let's say you want to upload data that have images, files, you want to upload them to a server from an Android phone, that's when you need a service, because it kind of need more CPU processing, and it will take a it will take some time. So that is when you need services. So in the beginning, there was the service component. So when Android started, actually, there was a component called service. How do you use that component? All you just need to do is to extend the service class. If you open Android Studio and you create a class and you type extends, if you extend that class with a service class, you will see that something service will come up. So that is the original, that is the basic service components that Android had.
Monroe, find me some tangible good.
And everyone here.
Wait, this
I
is
can
my
hear
case,
you.
okay? I've been working on this for 6 months.
All right.
He is actually used, detective. And this
All right.
matter we do have address.
So, okay.
You keep my pencil on for one day. Why don't you push the
Sorry, I noticed that everyone was muted, so having a chance to
What? What situation?
All right, so can I continue? If you are unable to unmute, can I know?
Yeah, you can continue.
All right, all right. Okay, so let me go back to. Okay, so as I was saying, I was talking about service. I'll just quickly round up. I'm almost done. It's 4:30. So the service.
You're not sharing your screen. You're not sharing your screen.
Oh, okay. Let me do that. Okay, so can we all see it now?
Yes.
Yes, it's visible.
All right. So I'll quickly round up very soon. So basically, so I was discussing about service that some developers misuse it. So developers didn't stop their service, because in service, by the time your operation has finished, by the time you've probably finished uploading stuff to the server at the background, you need to stop your service. But some developers ignore that action, and the service keeps running. Even though the operation has finished, the service keeps running. And as the service keeps running, it consumes battery, and some don't even release resources. So it is until a user entirely kills the whole application, that is when the service will actually stop. And there are some service that is even until the user reboots his device that the service will actually stop. So some services consume battery and resources. So they had to like put some constraints on service and create what they call intent service. So what is an intent service? An intent service is just like the normal service that helps us in running background operations, but this intent service can stop by itself. So what do you mean by it can stop by itself? It means that whenever the operation that a developer has put there to run, by the time it has finished running, it will automatically stop by itself. So that is basically what the intent service does. But as usual, a lot of people run stuffs on the background, which still consumes battery. So some developers also misuse the fact that there's an opportunity of running a background service. So, people have a lot of apps on their phone, and imagine WhatsApp, Facebook, Twitter, I don't know, all the apps that. So imagine they are all running background service and they are not killing, or okay, let's assume they are even killing the service, but they are running so many operations. Your battery will quickly run down. So that is what made batteries quickly run down, and the Android community had to look into it and now created what we call job scheduler. So what does this job scheduler mean? This job scheduler, it schedules a job. So when we talk about scheduling job, it means that there's a time for it to run. So what this job scheduler does is you create your background service and you are going to queue your job. That's the operation you want to do. You are going to queue it into the Android system. So if the Android system has space and memory for you, because before, if all the applications on your system are using all the resources and all the spaces, it means that a new application cannot run in the background, which would be a bad thing, which will make the application to crash. So imagine imagine Uber is running background service, Bolt is running background service, WhatsApp is running background service, Facebook is running background service. Then you that now created, let's say something like, let's say you create something like Mado app and it needs a background service. It means that your background service will not be able to run because a lot of applications are using background services. So they had to now put in what they call job scheduler that will schedule each background service. So it means that once your service is on a queue, the Android system knows that okay, it is meant to run this service. Then by the time one service has finished, it will now put in your own. So if there is space, it will quickly run your service. But if there's no space, your service will have to wait for one service to finish before putting it. So that's what the job scheduler means. So it means that job scheduler will not even, your service will not, if you're using the job scheduler, your service will not quickly run. It will have to wait until a resource or the space is available. But if there's space available to quickly run it. So, but this job scheduler is only available for Android 5.0 and above, which is Lollipop. So because it's only available to Lollipop and above, what about people that are still using Android 4.0 or Android 4.4, the KitKat and the likes? So that is where they now have to create the job intent service. So the job intent service is just like the normal intent service, but it is combining both intent service and the job scheduler. So it means that you have a service that is being queued and would also run in the background. And when it is done, it would kill itself by itself. But it's going to be on a queue. So the job intent service can work with pre-Lollipop devices, that's Android 5.0 downwards. Then there's also Work Manager. So this Work Manager is also similar to the job intent service, but the difference is that the Work Manager is used for it to run. You use it when you want your service to run when something is required. Like for instance now, let's assume you want to upload something to a server and you do not want any of that information to miss. Now, imagine someone that has 1% battery now and you are uploading something to the server and the battery now die, it means that that operation cannot finish uploading. It will stop. But if you are the kind of developer that you want the information to just come in at once, it means that you have to check the battery level. So if you want to check the battery level, you can use a work manager. So the work manager, you can use the work manager to set constraints that, okay, I want the battery level to be maybe fully charged. You can set that, okay, I want let's say the flashlight to be on. So you can set the constraints that you want for your service to run. So the job maintenance service and the work manager are similar, but the work manager works from Android 4.0 and above. So that is basically all on services. So if you want to write any service now, I will tell you to use job intent service or work manager, any of the two. So I'll just quickly do a brief demo on how to use the service. I might not run it because of time. So I'll just basically create a class called my service, and I can use this super class here and put a job intent service. So we can see job intent service here. So now this job intent service, you need to override this method on handle work. So this is where you place the method that you want to run. Then you also have to queue it. So the way you queue it is you can create a static, public static void queue work. So you call the function called enqueue work. So this enqueue work is already in the job intent service class. So you specify a context and you specify the class. So the class that I want it to run is this my service class. Then you specify the job ID. You can just put job ID 1 and you specify the intent. So like, let's say you want to pass in data to this my service. Let's assume you want to pass in a data to this service now. You have to use intent. So remember I said that you use intent to pass data between any components. So I can actually pass an intent, a data from my main activity to, I can pass data from my main activity to this my service. So I put in my work here, and the way I call it is, let's assume I want to call it from here. I have to create an intent. Remember that for us to start a service or for us to start any Android component, we need an intent. So I'm going to create an intent first. So this will be my service. Then I can now put, let's assume I want to pass the data inside. I can put extra, let me say number 100. Then I start the service by saying my service dot, okay, public static. Yeah, you should see it. So I can say my service dot enqueue work. Okay, dot queue work. Okay, so this, then I pass in this intent. So if I run this, now remember that if whatever component you are using, you must always place it in the manifest. So I must come here and place this service, my service. Then also you need to set this permission called bind job service, Android dot permission dot bind job service exported to true. So what this does is if you don't put in this permission, the Android system would not accept this service, because this is a job intent service. It's not like the normal service class that we have here. It's not like this normal service class. So it is a job intent service. So for the system to be able to accept the job intent service, you need to specify this permission here. So by the time if you run this activity, it will create this intent, which is to start this service class. And when you now run this queue work, it will enqueue your work here, which is this what you put in here, then it will run it. So that is how to use a job intent service. All right, so I will just quickly run on the last things, which is how to build a great portfolio. So how do you build a great portfolio? You work on projects. Like I've said before, you build stuff. Then I said upload on GitHub, because people would also want to know how you are doing on GitHub. Then you publish stuff on Play Store. Now, publishing on Play Store would make people know that, yes, you know the essence of delivering to customers. People want to know that, yes, you've built something live before. So no matter how simple your application is, try to publish it on Play Store so that you can know how it is to publish an application. Then other things you can do to build a great portfolio is to write articles, then make your CV a blast, and aim to work at big companies. So when you work at big companies, you would have experience on industry standard techniques. Now, how do you find opportunities? So firstly, you need to build a nice portfolio, like I said previously. Then you should apply for internships, just like how you apply to student. You can also apply to several other kind of internships. You can then apply for opportunities and expect rejections. Very important, because as a developer, you might apply for stuff. So even not just being a developer, for anything that you apply for, sometimes you might get rejection, sometimes you might not. But whenever you get rejection, don't quit, don't stop. Just keep trying and keep going. So let us stop here and take questions and answers so we can end this session. Hello, guys.
Yeah, hello, tell me.
Yeah, so do you have any question?
Yeah, there's always loads of questions to ask as regards, the job aspects, going through this, what do you call it, experience, and where the part where you actually mentioned that if you expect rejections, I think it's good enough that you actually said that, because for someone like me that I just started now, it's not as if I'm actually a pro. I'm still learning the trades, and I don't know, just pushing it. And as regards working on open source, can you just explain more on that open source?
Okay, so firstly, I said you should expect rejections. Yeah, so there are lots of people trying to also get opportunities and the like. So people was and employers will always want to sort. So the way you should try to like get the opportunities is when you have things that you've built, when you've worked on projects that people can see that and they can have competence in you. So that is why you need to keep on building stuffs and working on stuffs. So which is this to open source projects. So open source projects are basically stuffs on GitHub, like maybe something that someone worked on, and like maybe an app or something that someone put on GitHub. You can contribute. So you can just go to GitHub, go look at the Android, you can search Android on GitHub, and you will see a lot of Android projects on GitHub that is open. So you can always fork some repositories and work on them and create a pull request. So it will make you have something that you can see you've worked on. So sometimes you can just find a problem in a project. Like for instance, we discussed about ViewModel stuff. There are some applications that still use the MVP architecture. So the MVP architecture is an architecture that it was used in Android before. So it's called the Model View Presenter architecture. where instead of a view model, you're using a presenter. So, but the current trend is view model. So why not just look for a project that uses MVP and implements the MVVM architecture? The MVVM architecture stands for model, view, then view model. So the view model is what we discussed today, is the architecture. So you can do that. Then you can also like maybe optimize some code, write some things better. Though you might feel you are not too good, but you just keep on cloning projects, checking them, see what you can add, or maybe you should think of stuff on your. You don't necessarily. It's not by force that you even have to even work on operations project. You can have an idea on your mind and create it. Like when I was in University of Lagos, I just okay. There was that Namsin app I created was an app created by a set before me. So I just decided to continue that application and make it better. So that was how I was able to make it better and work on something. So that is just how you can, continue to build yourself and try to make things better. So I feel that's clear.
Yes.
Yes, thank you very much.
All right. So any other question? Okay, so it seems there is no any other question. Okay, so while there's no other question, we end the session. But before we end the session, if you check the slides, if you check the next slide, there's a task for you guys to do. So you guys should go through your task and try to do that task.
Yeah. Okay, we'll go through it.
All right. So
Yeah, thank you very much, Pelumi, for this lecture. Really appreciate it.
Bellamy, sorry, before you go, please just shed more light on. There are some terms you used in the task that is not really clear.
you said what?
Just shed more light on the task. Because
On
there
the
are some
task.
terms that you used, yes, and I'm just going through it now.
Oh,
I'm
okay.
looking at.
Okay, so the task said using activities and fragments, create an onboarding user experience that contains 3 fragments and a home screen that shows after the onboarding screen. So an onboarding screen is basically, when you just download an app and when you open it, like if you download when you download CarryWise app, you will see that it will show you save better, then you scroll again, then you scroll again, then it now show you and maybe get started or got it or something. So that is that is an onboarding user experience. So that is what I asked you guys to do. So for you to create such an onboarding experience, you need an activity and a fragment and a view pager. So the purpose of the activity is to host the fragments. Then you place in the fragments where you scroll through those items. So you can maybe check CarryWise app or check any other app like Google Apps usually have those onboarding experience. So it's when you first download an app, you see those kind of stuffs. So after you scroll to the last end, you see something like maybe get started or got it or okay. So when you click on it, the next thing that I want you to put there is a home screen. So the home screen can have anything. You can maybe put hi Taiwo or maybe hi Olamide or something. But then I now said when the home screen is displayed, run a service that displays a toast telling the user that the onboarding was successful. So what I mean here is when you've showed the home screen, then I want you to, from the job intent service that I explained, use that job intent service to start a service. And what the purpose of that service is just for you to create a toast. You know what a toast is now? Huh?
Yes.
Do we know what a toast is?
Yes. Yes, we know.
All right, so you just create a toast that will just probably say something like your body was successful or something. So it's just for you to be able to use all what we discussed today. That's just the purpose. So I hope it's clear. Any other question?
Sorry, just to be super clear, the 3 fragments will be for the onboarding.
Yeah. Is it clear?
Yes, it is.
Yes.
All right. So nice meeting you guys.
Me as well.
If you have any challenges during the project, you can reach out. You can reach out to me via email, or you can. I don't know if you guys, if you don't have my email, you can always try to contact or play me to give you my email or something.
Okay.
So I hope it's clear.
Yes, it is.
All right. Yes. That's super nice. Thank you.
All right. So
Sorry, can we reach out to you on Slack?
what did you say?
Can we reach out to you on Slack?
You want to reach out to me on Slack?
Yeah, I think it will be faster and easier.
I'm not on you guys Slack group, so I don't know how.
Okay. Okay, we'll figure something out.
All right, no problem. All right, take care. I hope today's session was okay. So
Yeah, sure. It was lovely. Thank you. Thank you.
Yeah, it was cool.
all right, goodbye, guys.
All right. We'll reach out to you shortly. Take care.
All right.
Yeah. Bye.
Yeah, peace out.